tuner. And if you visit our Zenodo repository, you will get the latest version. I mean, the February version, that is CNN parameter 2.0. That is a really stable version because that is fifth update of our software. And here you can see like what we the most of the features I told that we need to make it in our new updation for our first software that we already added here. I will just go with the one by one features. The interface and everything most similar. I will show that, but I will just go with the key features. Yeah, so you can load any image like JPG or PNG, and the users can also mention the dimension. If you want to deal with a dimension like pixel dimension like 90 or 150 or 250, or if you have really good RAM, just like 500 and so on. But I will not recommend for the normal system, just go with 150 or maximum 250. Yeah, and also the users can build their own CNN models. This is deep learning task. So the users can make their own model for the classification task. I will show the model how you can make that. And also customizing option like in our previous one, like training, testing, and validation. And also the main important CNN parameters. That is, if you are familiar with the CNN, you can see that the main fact is that we need to adjust in each process. I mean, each classification task. That the main thing is are epochs, like the training iterations, and also the batch size, like how many images we need to pass through in each cycle. Then the activation layer for the base model, I mean like the for the CNN model, we already added option for selecting the activation kernels and so on. I will show in the app. This activation function is for the final dense layer. So in this case, we must select either sigmoid for the binary classification and softmax for the categorical more than two classes. Otherwise, if you're just going with a ReLU or something in the final dense layer as an activation, definitely you will not get any good result. You will just get like 20%, something like that. So selecting the optimizer, you just need, it's also another important part in CNN, like optimization. So we also added all the available optimization and also the loss function. You need to predict the loss based on the already available loss functions. Like for the binary class, we like the just two class. We need to go with the binary loss functions such as um, binary cross entropy, and also for the multiple class, I mean the categorical, you need to go with the categorical or other, that I will also mention there. And also just like we are visualizing the result with interactive confusion metrics, and also here also added the option to for the graphs, like we can also see the graphs of training, testing, validation, and so on. Moreover, we are added an option like once you got a really good model, you can save it for the future use, like as a .h5 file. Like if you found a really good model, I mean, if you make a really good model with the software, you can just go and save that model, and you can use it later in Python, like the normal programming software. You can just use it and you can just use for your future work. Yeah, so I will just go to our main software, that is our CNN parameter tuner. You can see here, this is our fifth updation 2.0. So the same data, I will just show two class here. The first one, I will just show the exactly the same data, what we used there. So yeah, that is the sample, the same four classes. So you can see here in the comment prompt area. And here now we are going to make everything one by one. So in this software, we added more user options. So you can change the width, like if you want just 50-50, you can just go with the 50-50 pixels. Or if you want just like 150-150, you can just you just need to edit here, that's all. So we edited. So our input image size is 150, 150. Now we are going to the most important task, that is defining convolutional layers, because it's deep learning. So we know that I was showing that we have four species here. So that's why my class is four here. If you have two class, just need to insert there two, three class three, etc. So in our case, it's four. So that's four here. Then I need to make a convolutional layers. So initially it will only come with a single layer. So we need to add layer. We can just add like this, and you can make various layers like how much you want. So the first one is our input layer. So I'm just going with the 32 filter, then the 64 filter. Again, I'm just going with the 128 filter, then with 512 filter. So because if you are not familiar with this, you just need to go and study a bit about like the general principles behind the convolutional neural networks. And here also you can also edit the kernel size, but 3 by 3 is the best, I mean normal that we are using. And also activation function. This is the in the each intermediate layer, that also we are using ReLU because that is one of the good activation function for this. And once you define our model, if you want to remove something, you can also remove some unnecessary layers, because each one is convolutional layers. So I'm just going with the four layer. So I'm just creating the model. Yeah, so now we created the model. So you can also see the model here in the command prompt area, the your created model, all the details about the convolutional layers and the max pooling is also added in each layer. And you can see here all the things will be here in the command prompt area about the created model. And this model is nearly 3 lakh something parameters. So we are just going to train with this. So we just created our convolutional layers. And now we need to define our training testing. You can just use like how much percentage exactly like in the previous one, but here we added validation also with the same data. So you can define like how much like for the training, testing, and validation like this. You can also change there like, but I'm just going with the normal like standard one we are following here. And also epochs is the iteration. So I will say like normally if you want really good accuracy, you must go with really good accurate epochs. So writes like 50, 100 on something based on the data set size. But in our case, it's a small data set. I don't think like even, I mean, I think like even this 15 will be more. But anyway, I'm just going with the 15 epochs. So then the batch size, because we have only 121 image per class, so maybe I can just go with 12 batch size or maximum 14 in this case. Yeah, and the activation function for our final dense layer. So here I told that if we are dealing with a binary classification, need to go with sigmoid. If we are dealing with a categorical more than two class, need to go with softmax. Or if you are trying other these, you will not get good accuracy. So I will just go with softmax because we have four class. So we selected activation, and the optimizer, I will suggest Atom because Atom is really good. But if you are using RMS prop or some other Adagrand or something, there will be only minute difference, but I will just go with Atom. Yeah. So optimizer and the loss. So we are dealing with categorical. So I'm just going with the categorical cross entropy. If we are dealing with binary, we need to go with the binary cross entropy or mean squared error or so on. Yeah, so we defined all the parameters, and now we just need to go and click the classify. So it will load the image exactly like how we, I mean, how I show in the first software advanced machine learning classifier. So it will load all the image. And I believe that it will also take nearly 1.5 or nearly 2 minutes because it's, I told that we, while creating the CNN model, I used four layers, convolutional layers, and with various filters like 32, 64, 128, and 512. That means it's a lot, and it's created nearly 3 lakhs 80,000 or something like parameters. So that much parameters we need to train. So now it's just loading the image, and it will extract based on the what model we created. In our case, it's a fourth layer convolutional layer. So it will just use that model to extract the all features, then it will do the classification task. So I believe that it will just take nearly 1 or 2 minutes, so we can just wait. And also, if you are using the software, also please don't do anything else because it will consume a lot of memory because we are dealing with a lot of parameters and processing and so on. Even if you are using like either Python or R for the same script, it will also use a lot of memory because it's like a heavy task. And also, moreover, I told that our software is it's currently using CPU instead of GPU because we are planned to distribute to everyone because you know that most of them we don't have access to the GPUs because GPU is a bit expensive. Even I'm using a small laptop that's only consists of normal like Intel GPU, so it's not good for this classification task. We need something like a NVIDIA GPU and so on. That's why. Yeah, so you can see here the process happening like each sorry, no, epochs, how much accuracy we are getting and lows and so on. And you can see here we are getting nearly 70, 80%, nearly 70 percentage training accuracy. So all details will be visible like how we can see in our programming like Python or R and something like that. But I will say that in this case, I'm not sure if we will get really good accurate result because we just went with basic parameter values. If you are going with some other good parameters and more layers based on the data set size. Otherwise, we will also face the overfit problem. Like we will get really good accuracy, like 100% accuracy if we are dealing with small data. So so you can also check the results, what's happening here. Yeah, so we are almost finished. Yeah, final iteration. We just went with 15. And you can see that the training, I believe the training is above 90, but we can see in the detailed report. Yeah. So you can see, I told that it will not give you good accurate, I mean, good results because we just went with a small data and also the parameters were not good. So you can see really good misclassification here. So if you want to get really good results like above 80 percentage, 90 percentage, you just need to tune these values, like you need to change these values. And definitely it will because we used and we also got nearly 90 percentage. So yeah, maybe I will. Yeah. So you can, so now we finished the task. As I told that you will get the confusion matrix in the main window and all other computational results in the command prompt area. You can just scroll here and you will get even with the each layer, sorry, each iteration, you will get all the result here and also the detailed accuracy and so on in the confusion matrix. And also just like I was showing, like you can save this confusion matrix, you can save the classification report exactly like how we did in the previous software. Yeah, the other thing is I told that we can save this model that I will show like save model. Then I'm just going to use this CNN output. Okay. So I'm just saving like CNN model. So if we got like a 80 or 90 percentage accuracy and you think that okay, this is best model for my task, then you can save and you can use it for further. Like you can see here, now it's saved as a .h file and you can just use this model in programming. I mean, in Python or R, you can just use and you can just modify or you can do anything else there. Yeah, so the other thing I told that we can see the graphs here. And here you can see the graph is really crazy because we didn't reach really good accuracy. So based on this, you can also adjust the parameters. Like you can see like where is the problem while analyzing the graph and you can just change the parameters and you will get, definitely you will get good accuracy if you are doing that. And also you can also save this accuracy graph. So just take a folder like SCC graph. Yeah. So it will be there. Yeah, the graph is there. I mean, if you got really good accuracy and you want to write a paper or something like that, and then you can just save something like this. Otherwise, it's not necessary. Yeah. And also the same process like the options like the about menu and so on just to promote us. And also this is a part of one of our Horizon project called Reforest. So they were also involved in this project. Yeah, so you can just refresh and you can just do. I will also show a small classification like a cat versus dog, I think. Oh, no, not the cat versus dog, because this one will be a CT scan data. So here we are dealing with binary because I was just showing the categorical more than two class problem. Here I'm going to show the binary class. Here I'm just loading this data. I will show that data how it's look like. So just go for the data. So this will be the final experiment. So yeah, CT scan data. Here we have only two class. The one is defect and one is normal. So this data we took from a 3D CT scanner. That's a really giant machine that's in Slovakia. So we use this to identify, I mean, scan the wood logs, the really big wood logs, because it's a giant machine like a tunnel. So we used images. We were using logs to scan, identify good logs and bad logs. So these are the images of normal logs, I mean the good ones, and these are with the defects. You can see here the roads and so on the these are with the road. So yeah, this classification I'm just going to do. Just I want to show that it can work with anything, because in the initial classification, what I was showing, it was just with the tree species classification with the bark images. Now we are using a CT scanned image data. So I just load the data. Then I will just go a bit quickly because the same process. Yeah. Then the conventional layers here, we are dealing with binary class. So we have only two. So that's why I added two here. That is important because if we are dealing something like four here, definitely the accuracy will be really crazy. So here, yeah. So created the model, then training testing again, 70 percentage, 10 percentage, 20. So if you want to check, it's added there. You can also check there. Yeah, epochs. I will just go with the two. Yeah. Okay, maybe 15 epochs. Batch size 14 or 15. Okay, 15. Then activation function, because here we are dealing with the binary, so sigmod is best. Then optimizer, also add them, because I prefer add them. Then loss, here we are dealing with the binary class. You can just go with the binary or mean squared error. So I'm just going with the binary. So that's also we are just doing the classification. You can see here the images are loading really fast because it's really small, and also it's just binary class. That's why. So here also, I'm not sure. I think here we will not. Yeah, here we go. Because you can see here, there is only few data. You can see here the classification results are really high, 100% overfitting, because the data set is really small and the parameters what we gave, that is really high. And I will just show here. Yeah, you can see here how many parameters. Yeah, this, like you can see here, this many, like 93,000 parameters for the simple data. That's why we got really good accuracy. And also the data set is really small. And also you can see here, if some images are corrupted, it will not load. It will just show which image is corrupted and it will not load, but the system will work. You don't need to worry anything. Yeah, the same accuracy result here, you can see here. Yeah, so that's all softwares.